Solving equations. When we're solving equations, we're always going to take the terms that are on the same side as the x and move them away from the x, because we want to end up, the final answer should be x equals. So we want to get the x by itself. When you're solving equations, you want to think about it as BODMAS in reverse. So BODMAS is normally your brackets first, then you're dividing and multiplying, then you're adding and subtracting. But that's when you have been given a sum that you're going to work out the answer to. If you consider an equation, we know the answer. What we're trying to work out is, well, what was the sum? So that means that we're working in reverse. So you're going to start by moving anything that's adding or subtracting from the x, then anything that is dividing or multiplying. Brackets are a little bit different, but we will get to those. Adding and subtracting, so we have the 6 is adding on to the x, it goes to the other side. When you change sides, you change jobs, so it becomes a takeaway. That gives me a final answer of x equals 4. The 3x is multiplying. That means 3 times x. Now there's no adding or subtracting, so I can go straight to the multiplying here. So the 3 has to move over. Now the opposite of multiplying, because remember, change sides, change jobs, is dividing. So x is 15 divided by 3. That gives me an answer of x equals 5. This line in a fraction, remember, means divide. So this is saying x divided by 8 is 4. So the opposite job, if I bring the 8 over, is to multiply. So x equals 4 times 8. X equals 32. So this is our first example with combined things. We have 2x, which is multiplying, and we have plus 6, which is adding. Remember, BODMAS in reverse, so get rid of the thing that's adding first of all. It is really important that you lay these out correctly. Now when I'm doing equations, only one thing ever moves in a line. So the next line, the 2x is still there, the equals is still there, the 20 is still there, but the 6 has moved. And remember, when it moves, it changes its job. That gives me 2x equals 14. And again, only one thing has changed from this line to this one, and that's that I've calculated the answer to 20 minus 6. Now the 2 needs to move across, and remember, it's multiplying at the minute, so it's going to divide on the other side. And again, only one thing has moved there, and that's the 2. 14 divided by 2 is 7, and that's your final answer. Again, in this one, BODMAS in reverse, deal with adding or subtracting before dividing or multiplying. So this gets moved first. So we end up with the x over 7 stays exactly where it was, equals 5, but the 4 has moved and becomes a plus. So x over 7 equals 9. Next, bring your 7 over and multiply. And remember, if it's dividing on the left, it will times on the right. So that gives me a final answer of x equals 63. Okay, now I said that I would get to brackets, that they're a little bit different. With brackets, what I would recommend that you do is just multiply them out before you start thinking about solving your equation. So 4 upon x plus 2 becomes 4x plus 8 equals 32. So the 4 has multiplied the x, the 4 has multiplied the 2. Solve it normally now. Adding bit comes across first to give you 4x equals 32 minus 8. So 4x equals 24. And then the 4 comes across. If it's multiplying on the left, it divides on the right. So we get x equals 6. Now, this is where you have equations with letters on both sides. So, what you always want to do, first thing, is find the smaller amount of x's. Now, that means that you completely ignore the other numbers, and all you're looking at is the x values. I have 2x, I have 5x. What comes after them doesn't matter. 2x or 5x, which is smaller? The smaller one moves to the other side. Now, everything else stays where it is. Remember, only one thing moves on each line. So 6 equals 5x minus 6 minus 2x. So my 6 has stayed the same, equals has stayed the same, 5x has stayed the same, minus 6 has stayed the same. 2x has moved over and changed its job. Next step, simplify that. 5x, take away 2x, is 3x. And then solve this normally. This is now exactly the same as the previous equations that you've done, so don't overcomplicate it. Move the adding or subtracting first. So the minus 6 is going to go over to the other side. To give you 12 equals 3x. And we need to bring the 3 over and divide. 12 over 3 equals x. Final answer, x equals 4. Last example. Which is the smaller amount of x's now? Negative 3x or positive 1x. Remember, negative numbers are always smaller than positive numbers. Now, please note the difference here. If I flick back, I just consider the previous one. It doesn't matter if something is being taken away from the x. What I'm referring to here is that this x is a negative because it has a negative sign right in front of it. So this is the smaller amount of x because it's negative 3, whereas the other side is positive 1. My 12 stays where it is, my equals sign stays where it is, my x plus 4 stays where it is, my 3x comes over and does the opposite job. X plus 3x is 4x. And my plus 4 is still where it is. Again, remember, only one thing's moved there. The 12 is still where it is, equals is still where it is, 4 is still where it is. All that's happened is I've combined the 3x and the x to get a 4x. The 4 now needs to come over, because I'm solving this as normal now. 12 take away 4 equals 4x. So 8 equals 4x. 4 needs to come over, and it's going to divide. 8 divided by 4 is x. Final answer, x equals 2.